All right, let's get into it. My name is MJ Smith. I am VP of Marketing at CoLab, and I'm going to be moderating today's session, which is going to focus on simplifying the handoff from design to production for Stage Gate NPD. And we've got our speakers, Oleg and Adam. So if we kind of zoom out and think of the product development process as a whole, we're going to be speaking a lot about the gate and a lot of the processes that happen around design validation, moving into production validation, and how we can think about making this gate a little more stress-free in the future. And so we're going to talk about how you can make your workflows here more effective, and maybe how we can bring some of the risk that is inherent in this gate forward into some of those earlier stages to make this a little more stress-free in the end. The reason that we want to focus on this part of the PD process today is twofold. First of all, it's very high stakes. So you hear a lot about expensive mistakes either getting made or more often getting caught right around here. So things like investing in tooling and finding out that you need to change the design, or unfreezing a design after you really hope that that design freeze would have stuck. And then also it tends to be very cross-functional. So the workflows, the processes, and the technology you use can have a big impact if you're able to consider the true cross-functional nature of what happens at this part of the stage gate process. So to help us out today, talking about all of these topics, we have Oleg, co-founder and CEO of OpenBOM, and we have Adam Keating, co-founder and CEO of CoLab. And both of these guys have lots of interesting takes and a lot of experience looking at these processes and workflows around this part of StageGate. And I don't think anybody introduces them as well as Yuri up here. So he calls these two guys the future of product lifecycle management at one show. So thank you, Oleg, for joining us. And thank you, Adam, as well.
Thank you, MJ.
Thank you for
all right. Let's with that, let's jump in. Before we get into it, I will just prompt everyone, if you have questions for Oleg or Adam, or if you have comments, or if you disagree with something that they say, feel free to put it in the chat or put it in the Q&A, and I will bring up those points or those questions either as we go or at the end. But let's start with this topic of design freezes. So I alluded to it a little bit as I was opening things up. Sometimes you really hope that your design is frozen, but then you kind of move into production validation and you find out something, whoops, at the end that causes you to have to unfreeze the design and make changes that tend to be very expensive. So Adam, let's open it up with you. Why do you think this happens, and what do you think are some of the ways companies can start to solve for that?
I mean, I think the first question is like, do you actually mean it? I think in general, it's an idealistic frame of reference. And because of the way we look at things together and make decisions, it's often back weighted. If you look at sort of the cost of product development, obviously up front, any change or thing you save there is going to save a ton of money, but we still wait till the very end, where making a change is super difficult because it's not easy, right? Like Oleg and I have talked a lot about this one-to-one, that it's not easy to look at the same model. It's not easy to share the same BOM because the rate of change during development is so high that there isn't good ways to be doing that. So what happens is you get, a pack of drawings or something that comes out, and the first time a supplier sees them is at the 11th hour. And all of a sudden there's a breaking change. Or worse, you get through that, it gets approved, and then it comes back that there's a problem, and then you're going back to a design that's frozen and also making changes. So I mean, I think in general, people would like to think that it's frozen. I've seen a couple of rare examples where there hasn't been a ton of change. And those teams have really focused on pulling forward review. Like if you go back to that stage gate process you were talking about, I've seen people take, design verification, validation, and almost say, we want to kind of do that in detailed design. Like those checks that would typically happen in that gate, let's almost pull that forward, even the formal parts of that. So that by the time we get to design verification validation, where we're trying to freeze things, we've kind of already done that. So any of the little hiccups that happen, we've pulled in. But I mean, like you've seen it across companies for years now. What's your take on whether people actually mean this and how well they're doing it today?
Yeah, it's a very good question, because we like the steps, we like to say freeze. Okay, it's a kind of word that brings a lot of good feeling. Oh, we've frozen again. It happens in design. It happens in software, going back 20 years, I can say, oh, we love this word to say code freeze, right? But what does it mean? It's actually happening. It's obviously not. So I think there are two factors here that I would mention. So first, everything is starting to be more complex. The meaning of doing freeze by a single person is pointless, and making freeze by a group, it's very often a joke. So it's not about freeze, it's how to get in our iterations closer to the end. So that's why the all stories of agile development, it's about how people in the complex environment can collaboratively move forward, getting to the point where it can actually work and they're getting what they need. Because then there is an infinite proximity that you want to get to this. So it's not really freeze. And the second thing is the how to make work together between multiple teams. And you're right, Adam. I've also seen situations when people can pull it through and they can do freeze. And again, those just exceptions. So I'm looking into two things. First, how to make something in the complex environment where the coordination between teams and coordination between people is important. And second, how to put this iteration. So I would be replacing freeze with these two things about how team can go to result in the complex environment faster. So that's what we might take.
There's a really interesting part on sort of like that iteration comment. There's like two blockers, I think, to it. One is it's not easy. It's not easy to iterate. It's not easy to put your work out there and get feedback. It takes time and effort. The other part is it's like a cultural thing where many teams don't want to be getting stuff picked at early enough, and they want to kind of polish. I mean, we even see it in software development where, we're talking about days usually between iterations, whereas, in hardware, we're talking about months on most cases. We see it on the day scale where people are like, oh, I want to wait until it's polished after 4 days. But I'm like, just put the thing out there so someone can see it. Because like when you think about, scoping a new product, you want to get those high level requirements right up front. You want to start thinking about the key components and systems. But then as you're looking at the different parts of that subsystem or the components, there's no reason you can't start knocking that off and having alignment early. And I think, as you go through that, once you get that kind of mindset, it becomes contagious that culturally it's okay to share something for an early review, go through some revs on that, and then, button it up at the end, because you should be getting a ton of feedback up front and nothing at the end. Today, it's the opposite. You get nothing up front and then you get everything at the end. And like, I'm guilty of this too. Like when I worked as an engineer, there was things that I worked on where I held it close to my chest until it felt good. And then I'd show it and they're like, no, you've completely missed this key requirement. And I wasted 2 weeks or 3 weeks or a month, working on something. And I was doing smaller components. So you can imagine now you got a customer in an automotive program who's working with a big tier one, where they're completely off base. I saw just recently a tier one where they went all the way down this path of adding in something the customer had like offhandedly mentioned. It was going to add, $20 per product to every single thing that they created. Their VP never saw it until the very end. They were about to enter PV. And he literally said, we shouldn't optimize this. We should rip this straight out of the design. And imagine going back to the customer now who's about, to expect tooling and say, we're cutting this whole thing. It's way too late, right? And I think if you got that person in there earlier, you could have saved yourself a ton of pain up front. So I think the whole thing, like you said, is that iteration speed. And it's being okay with getting something out there early and often. Be clear about what you're presenting, the status of the design. So that when you get to the end, you're kind of just getting there with a rubber stamp because you have done all the hard work in the early iterations.
Yeah, you hit a very important point in my view here, because again, technologies are easy and people are very hard. And when you work with engineers, there are some elements and there are some engineers that might not be going well with this, and that's, again, it's a cultural change. You want to share, you want to be in an environment that you're ready to share, you're open to share. It's something that people take it seriously. I want it to be perfect before I will show it to anyone, and then guess what? There is no point. it's really up to human environment and also company environment and also technology that make it easy without punishing people for sharing something that's
and one story before we move on. I spoke with this prospect a while ago, and they said something really, really interesting to me. I wrote a LinkedIn post about it at one point, and they said, I was saying, we want to make design review easy so that you can have more of these conversations, make the iterations possible, the rest. And this person stayed after the meeting and actually called me out on it and said, design review shouldn't be easy. Like steam coming out of ears. Design review should be hard. And I thought there for a second, I was like, what does this person mean? Why would you want it to be hard? And what he meant was the review should be intense. Like you should be going thoroughly through a design and actually providing that know-how. And it's one of the most important things people do. And it's interesting because I actually meant the same thing. I meant lowering the barrier to be able to do a thorough review. But it's just such a simple semantics. And the response he had was, I think everyone should just be in person because that's the easiest way to do that. But it's not practical anymore. So back to the technology point, Oleg, it's like, how do you combine those two different mindsets? Because in my head after that, I was like, okay, we need to prove that it's easy to do and take away some of the administrative work, but you can still be super thorough, because his point was fair. He said people mail in their design reviews now. They go look, they click a couple buttons, they don't actually provide know-how. And at the end of the day, that still comes out to be a change down the road. And I think that was fair feedback. So it's something to think about there too, with the cultural piece about even what do we mean by iteration speed? We don't mean that you rush reviews. We mean that it doesn't take 3 weeks to book a meeting with 15 people to sit in a room together. We mean you can do it asynchronously and still provide the same level of critical thought. So last thought, and I'll turn it back to you, MJ.
Yeah, there's a couple of questions on this, actually. The first one is, one of the things you both talked about is pulling risk forward into those earlier stages of stage gates, so that, for example, the first time a supplier is seeing something is not at PV. It sounds good in practice, but I think a lot of people would say it's not practical. So what are some of the practical steps or challenges that companies can solve for to start making this more of a reality?
Oh, do you want to go first?
Yeah, I think the practical is the environment in what people are organizing their work. So I will take it in my environment. So when everyone is accepting Slack as the way of collaborating, try to introduce email back to this environment, and everyone will be screaming and yelling at you and saying, no, go back, because this is the environment that people like to work with. And this is something. So I think taking the environment that people like, make it comfortable for them. That's the turning point. And yeah, it will be old timers that will say, no, I want to get at emails and I want to read them every 24 hours. But that the result will be obvious. And after some time, people will realize it just cannot work.
I think too, it comes back to expectations. If you're clear about what you're sharing early, we've been hearing this theme of co-design emerging as a topic where people want to bring in trusted partners. And we don't mean every supplier, but your key supplier who is building, a big subsystem for you. They shouldn't be coming in later or given a package of information thrown over the fence and coming back with a design 6-12 months later. That's just not a good way to do things anymore. You want to bring them in right up front. So it depends on the program. If this is a brand new product, no history, that's one thing. Most programs aren't. They're based off some other derivative product or a new model. There are so many lessons learned to start from there. And there are so many places where you can say, here are the 3 or 4 key subsystems that we need to nail down suppliers. So think about automotive. Everyone going to electric, they know how to do a suspension system for the most part. The core system is going to be the battery pack, or the core system is going to be some of the intelligence and how they re-architect the mechanical systems around now, skateboard technology. So I think that's the way to think about it, is not all treated equal. It would be what key strategic things could cause pain here? Who are our strategic partners? Bring them in up front and be very explicit about, which elements of this you want to get nailed down early, so that you're not having breaking changes introduced at the end because of something new.
Definitely. One other crazy simple thing is that I think often people hesitate to bring in suppliers until the end because they can only send them a 2D drawing and you don't have one until the end, right? So if you can create ways for a supplier to collaborate and weigh in on a 3D model, which you might have earlier in the design process, that's just a very simple technological hurdle you can overcome for your team. Another question here. One of the challenges in design freeze is some of the sub-modules have long lead times. When the whole BOM is still being iterated, some of them have to be expedited or break away. What best practices have you seen around this scenario?
I think kind of where I was just going a moment ago is like where I'd go back to. I think the long lead or critical components of that timeline are the ones you need to get up front and have strategic partners for. I think you're seeing it more and more now that having that up front and being clear about what that system looks like and doing even more intense review on that and making it easy, to Oleg's point. If it's not easy, it's not going to happen. To do the facilitation, people will go back. They will not want to do it. You need to really treat those people like they're partners if it's relating to a supplier. And that's not easy. Like Oleg and I will talk about at some point here, PLM technology. It's not easy to log into Team Center of someone else's company. It's not easy to set up an expensive CAD tool. These are complex pieces of software. And on the other end, you might have a massive tier one, you might have a small machine shop. Getting them all working on the same data is a very big barrier. So I think the two things for me would be, thinking about how easy is it to get people the access they need to that data to be truly partnering, and then two, just being very specific on which ones need that type of review and pulling that all forward.
Yeah, I think the answer to the question how is share early. If you can share early, you will get risks down, and how to do it is just bringing tools. I think we are on the same page about just offering tools to share a BOM early, tools to share a design early, reducing the barrier to get into this, and then if you can share early, obviously you reduce the risks.
I'll tell you a good way to know if you're doing this. If the person on the other end has to think about what tool they're using, you probably got it wrong. That's a pretty simple way. If they end up going in and they click a link and they end up in a BOM and they don't ever know it's OpenBOM, besides there's a logo in the corner, you've probably succeeded. That's probably the best way to think about it. If they're frustrated with, oh, I can't get into this FTP site, blah, 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 you probably got too much friction there. It needs to obviously adhere to security controls, but there are so much smarts built around doing that well today that it should become almost effortless for the other partners to be part of that ecosystem.
Awesome. I'm going to move us on to the next topic, but I think just in summary, understand what your cultural expectations are around the term design freeze. Mark made a good comment here. Sometimes design freeze implies done. People interpret that there's no more work that's going to happen after that. Maybe that's good, right? But it just depends. Everyone needs to be on the same page about what that term means. If design is still in process, people are hesitant to freeze it when it's interpreted as pencils down after the freeze. So what do you mean by design freeze? Really get on the same page, and then bring as much risk forward as you can. And sometimes that's just a matter of being, offering more simple ways for people to participate earlier in the process on 3D, on BOMs. Those might not exist in your organization today. So that's a good place to start looking. All right, we're going to move to drawing releases. So kind of similar, but like mistakes often get caught when you're releasing drawings to suppliers. What can companies do to catch these mistakes earlier? And in particular, Adam, maybe you can talk a little bit about Mainspring Energy, who recently completed a project where they had to release 300 drawings to suppliers, and they had no errors during that process. What are they doing differently?
I think the first part is like a drawing exists to clearly communicate some form of design intent for something to be manufactured. Oleg and I had a conversation earlier about, over time, will drawings go away and move to NPD? Yes, the time horizon for that, who knows? It's a bit of a gift and mystery at the same time. But when it comes back to it, you're trying to communicate something that is final. And I think the thing that was different in the case of Mainspring, which I thought we've seen it across some companies now doing it well, is they weren't doing drawing review with just engineers. They had their manufacturing team, they had their design partner, they had suppliers as part of that before it was ever released. Like, it wasn't like the supplier who was about to go build this thing saw it for the first time when it came over with the PO. They were involved in that process up front. And because of that, it took way less time because they caught the feedback when they were already iterating. So back to MJ's point about design freezes, they were doing like I'll call it a mini freeze for now, but they were kind of like here's an early cut. Let's go through this. They cycled through, made the changes, incorporated some good ideas, actually saved a bunch of money if you read the case study because of that. And then by the time we got to the end, it was like, we're already aligned here. We've already done all those checks. So it became much more of like just putting the polishing touches on drawings rather than the clarity of the communication about the design intent itself or the manufacturability. So I think that was the sweet spot, was having manufacturing team, design partner, and sort of then suppliers all looking at this together. So when it came time to put the pencils officially down and start, cutting metal, they weren't looking at something for the first time. It's kind of what I would see. And I think I've seen it go completely the opposite direction, where people are shipping it the first time and then they're coming back. There's a company we worked with that at one point they were telling us that customers were reporting 12 errors per drawing package, and that was becoming problematic. They basically engineered that out by saying early in the process, we're going to start tracking what those errors are, training the team, drilled that down to under 1 per package. That became, though, because they started iterating on the stuff earlier and tackling the most common stuff. So Oleg, I'll turn it over to you from there.
Yes, I think the idea is stress-free. Again, it cannot be stress-free. It's always will be stressful. So do not expect things to be easier. But I would like to turn it in 2 aspects. So first of all, bring more eyes. That's certainly helpful because 4 pair of eyes can see more than 1 person. And the second thing is bring more technology, because just let's invent technology that can check it. And this is where AI will be showing more and more. And I will just compare it to the writing. Like, can we write without mistakes and publish something with the first click? It will be mistakes, but we have now tools that can check, that can highlight, that can do, So I certainly expect to see tools that will be able to check drawings and tell us, oh, this is wrong and this is wrong, based on the huge database of drawing that was already analyzed before. This is where a technology will play a role. But technology is not perfect, and that's why more people. So collaboration plus technology, those are 2 things that will play into stress-free. And then yes, I'm much less stressed now when I publish my article online after all tools checking my article. So the same about software code, the same about design. Just need to make it more intelligent.
I think there's something interesting there, like on the AI side, over time you'll be able to use this up front. I think now, like, one of the things with technology, whether it's OpenBOM, CoLab, or another tool, because that stuff's not inside of a random Adobe downloaded application on your desktop, it's in a connected system. We're going to talk later about how this all data connects together. So give you an example of another company who did a very successful drawing release package. They basically looked at and categorized all the feedback into different types, and they didn't have to do it manually. The system did that, and because of that, across 100 engineers, or about 100 engineers, they could see basically a curve of what the tail looked like. And out of all the mistakes that happened, let's say like 95% of them happened very rarely. There was the 5% though that happened between 10 and 24% of the time. One of them happened 24% of the time across almost 500 drawings and across 100 people. So by training the people then to say, like, here is the common mistake that's happening, that went away. And if you take the top 5% out of that, the number of actual errors goes down by a factor of 80-90%, because the rest of it was a long tail and kind of bespoke to a particular drawing. But it's a really simple concept that's impossible to do without technology. It's something that I think Oleg and I both have some interesting ideas long-term on. How do we just put that in front of people so that it's not, a human effort to go counting things on drawings to see how well it's going.
That was really good timing, Adam, because somebody actually just asked what types of errors were being found on drawings once sent to suppliers. So is there anything you would add, given that you know that's a question?
Yeah. I mean, honestly, in some of the cases that had the more extreme version of this, it ranged from everything from, I would call it like more sloppy design work, where there was missing dimensions, tolerances, materials, all the way to like fundamental design mistakes. I think a lot of the easy stuff was able to be caught by just saying like, here's how you properly tolerance something, here's how you properly define materials. That became almost like training sessions with the team. And what they found was it was because this team was scaling up pretty quickly. So they had hired a lot of junior folks. They were coming into a new program. They were all kind of making the same mistakes. That's like one end of the spectrum. The other end was like proper design mistakes. If we can't manufacture this, it isn't going to work. And that's because they didn't bring the partner in. That took a little bit longer. That was a little more tricky. They're also more costly, of course, because if you don't catch it, you're going to build the wrong thing. But I would look at it as like those two buckets. Most of the time, though, it's mostly in bucket one. It's like sloppy stuff where people don't even realize they're making the mistake continuously because it's only one person seeing their silo. And if you notice across the team that everyone's screwing up a particular thing or over tolerancing something, you can go back and actually fix that when you have that kind of data.
Yeah, I would add one more thing on this. The historical perspective, it's very important. And I think, Adam, you and me discussed it recently, that keeping track of history and changes, you can find patterns. Like, hey,
Oh, yeah.
you already fixed it 5 times before. Why are you doing it again?
Well,
that's kind of thing that can come again technologically, can bring it back to people.
I'll tell you an interesting thing on that. So like even just thinking about, so let's think about simple drawing review. So if you were to do that through CoLab, each review of any version is stored against itself. You can pull that data through one version to the next. It keeps an audit trail for you. So if you want to go back and see how one thing came to be later on, you can see it. If you go through an audit 2 years down the road and something did go wrong, you can go back and see the design decision. Having all that there too is like, I think, additional peace of mind, because that amount of work to document that stuff properly is like A, not a good use of time, and B, substantial. And that's where the data comes from. So it's like a kind of 2-for-1, right? You get the data to learn how to be better, and you don't have to do all the extra work, and it's easier for the person to give you the feedback. So it's a tricky thing because there's a mindset shift. I told this story before, but I had a gentleman who looked at CoLab 4 years ago, and he told me, I've been checking drawings for 20 years. I'm never using this tool. I like using a pen and I don't care for this technology. He actually told me I hate CoLab. That was his specific framing. And a week into it, I called him to see how he was doing. And he told me he loved CoLab. And I was like, now, how did you go from one to the other? And for him, it was because all the other garbage was gone. He was no longer trying to track revisions together, upload stuff to new places, scan stuff back in, create histories, note stuff, track how many errors happened. It all went away. So he accepted the fact that he was now digitally using a pen instead of a physical one. But it's the combination of it being like easier, automating the crappy stuff and giving you a bit of data that I think really makes that work for drawings. And down the road, like bill of materials, 3D models, all engineering artifacts, I think will go through the same evolution step by step.
To throw another layer of complexity in here, Oleg, I know we talked about cross-tier supplier collaboration a little bit coming into this. Can you share some of your thoughts on that?
Yes, that ultimately goes to complexity. So the reality is that we are working in the very complex environments today, and data is not visible across tier collaboration. So that's something that ultimately brings the question of how we can explore these relationships and how we can bring data. Adam was talking about data gathering and data analytics. I think we discussed it multiple times. So something that can become visible cross tier can bring really improvements into design process. So having this information earlier can help to people to eliminate mistakes, and having this data and having this intelligence, this is what will differentiate between the current environment. And Adam, you was talking about someone who was using pen and now using something else. Yeah. I mean, the same difference will be happening in the tools that will be able to see the relationships between components provided by different suppliers, the visibility on what is provided by purchased assemblies, the visibility and dependency. And again, we will talk about this more later today, but that's something that helps discover relationships that are not visible now.
Adam, I know you probably have some thoughts on how cross-tier supplier collaboration can add to like security and data control challenges. Can you speak a little bit about that?
Yeah, security here is like, it's an interesting topic because I think in any case, it's paramount. But if you go back to what is like today's status quo, even if you're using an FTP to your tier one, let's say you're an OEM to your tier one, what's happening after there? Like, ask yourself that question. The data is then going via email, most likely, to a tier two, and then it's out in the interweb. So like the current status quo of how this stuff is shared is not good to start. And even if you're using an FTP, once the file is downloaded, it's gone. So like one of the key things we've said up front is like, can you make it A, easier for them to access, and B, more trackable and traceable for the company? And I think that's true in the case of a bill of materials too, right? There's a lot of data in a BOM. The second you send it out in a spreadsheet, it is A, no longer tied to anything, and B, just out in the wild. Can you keep that in the system where it's easy to use? And I think that's true. I think you can. We've seen it. There's some cases, yes, you'll need to pull down a 3D model to be able to run an analysis, but a drawing is mostly being viewed. So for that use case, like, you know, if you're sharing something through CoLab, you can put it in a viewer that you control. They can download it right off the hop. You can control if they can add other people to it. I think that's an opportunity, but it's something to think about as like a cultural shift, because just letting people not download, but making it really easy for them to view is a huge benefit. And it's happened in many other industries already. Like it went so far in the investor world of like software startups, that companies like DocSend started to basically track PDF viewing because investors were taking confidential information and sending it to everybody else and their dog, including competitors. And you had no idea. Now you can tell in DocSend if an investor invites a competitor to look at your PDF because you ultimately can't get it out. That's an extreme example, but I think if you think about the nature of security breaches today and the world we live in, being smart about drawings, there's been a lot of breaches in the last couple of years, and oftentimes it comes from the supply chain. You can't engineer that out. There's different maturity levels of supply chain. If you've got 1,000 to tens of thousands of suppliers, there's going to be some small ones, and the best thing you can do is do the work on your side.
That's true. I want to take this example of sharing documents, and in our case, like everyone is sharing bill of materials as Excels, and like you said, the moment of time you share, it's gone, and you cannot control it, and you cannot split it between different pieces that you don't want to share. You want to share this piece, but not another piece. Like when people realize that they can share a slice of bill of materials with the right people and the way they want, without separating them in separate pieces, like taking stress out of the entire operation, and that's what also gives them control. So I think we see the same appearance, the same pattern in different industries coming again, and that what, like your example of login to Team Center, which is hard, and you just need to get a link and log into another system. That's all patterns of making something easy and controllable at the same time.
Thank goodness I didn't use stress-free again. I'm a humble marketing person, right? Sometimes I exaggerate a little bit. Okay, so here we have effective ECOs. So I'll start with you, Oleg. We were talking ahead of time, and you have a lot of interesting ideas around the future of how teams are going to use knowledge graphs and impact analysis to improve their decision-making around ECOs. Can you speak a little bit about that?
Yeah, absolutely. ECO, it's a fascinating topic because, you know, it was something that was called change control board. And if people remember what was that, was this literally board of people, you know, sitting together around the table, taking pieces of paper and then signing or not signing, and that was all their decision. The systems that came to manage ECOs today, the typical thing, if you ask someone about ECO, They said, oh, it's very simple, it's workflow. So what was very fascinating around is that workflow, although it looks very visual and very simple to someone who defines it, then became a very, very complex thing, because you don't actually know what is happening in what part of the workflow. And then you have a part of the workflow when someone went to vacation and it's not moving and no one knows about this. So one of the things that's very important for change management that we've seen over time, the first is the visibility. So what is actually happens with, with the change visibility? So who is actually holding the process? So what are the dependencies? So those two questions are always asked in any change management processes, and there are not many immediate answers if you use traditional thinking about change process as a workflow, because no visibility and not enough information about dependencies. And this is where I coming in these conversations about knowledge graph and conversation about dependencies. So you need to have enough information about dependencies of the product and the dependencies of the components and changes. And this is the information that's usually very, very, very hard to pull together. And if you go with the complex environments and complex machines, it's just getting enormously complex straight out of the beginning. So all these dependencies are undiscoverable. The people that should be getting involved barely can touch it because, yeah, someone didn't approve it before. So all this is the environment that going to change a lot. And again, the change control board CCB was sitting in the same room, and now people are sitting in different environments, in different places, and different companies. So how to make it all together, that's what will require a different approach, also from data management and also from collaboration. So the first will need to bring all this information. And the second should bring people. So again, speaking about how to bring people and data in the same environment to make this approval easy, and also make analysis about what happened before. Those are, again, it sounds like I almost getting myself thinking it's all the same topic with drawings, the same topic with the release. But yes, it's how to bring right information in the right place, and communicate it in the way so people will easy understand what is going on. So that is, and at the same time, be formal. So I think our experience in this field was that by bringing collaborative layer to change orders, that's something that can help people to get more information and be more aware about changes, and just be knowledgeable about changes that are they doing and approvals that they're making.
Yeah. Last week, a couple of us went down to the user conference DESO co-experience, and one of the major topics there was model-based systems engineering. And there's the same thing is going on with requirements, right? If one requirement changes, there's a cascading effect on all kinds of other things you have to pay attention to during new product development. And companies are right now sort of struggling to figure out how to stay on top of the impact of a single change. Sorry, Adam, you were about to say something.
I was literally going to say the exact same thing. But it's interesting because I would actually describe the challenge with change orders in particular to be twofold. And Oleg, I actually did have one of those change control boards that was in a physical boardroom back early in the day. And I do remember bringing actually like a paper package of something someone had signed for me in the office. I used to walk it around and get it signed off. So I do remember that. That was fun. But there's kind of two sides to this, right? One to me is the data side of this, like actually knowing that you've got all the pieces connected back to understand what is really the change. The other then is like the communication layer of like telling somebody what is the change. I had one OEM describe to me that they make so many changes over the course of a year on a particular vehicle that when they send it to somebody who's using that downstream, like a partner or a supplier, that they basically tell them they either miss the change because they don't look through it, or they get a phone book full of changes that are really hard to understand. And it's just like a constant battle keeping up with it. I'm curious, Oleg, on your perspective about the data side. We can talk about the communication side in a second, but on the data front, how do you see this working out? We've talked lots about systems of record, system engagement, all this data plugging back together. Companies talk about this all being in one tool. We all know that there's a bunch of tools where this data lives, from a requirements tool to an ERP to your PLM. How do you see the data part working well so that the knowledge graph actually has the rich information to be impactful for like a meaningful impact analysis? Like how do you give feedback to a company to be good at getting the data part right?
That's I think it's an excellent question, Adam, because it brings up the question of how to make data first citizen in engineering and manufacturing environment. Because remember, until now, the first citizen was the system. Oh, we want to be good, so we need to buy this famous ERP system with 3 letters, right? That everyone runs well and everyone is very successful with them. Look at them. But so that's how ERP made their path in the systems. And then it didn't work, or something didn't work. And then, oh, now PLM will solve all problems. So I had a conversation with someone online a couple of days ago. And again, the one system didn't help. Let's bring another system.
Yeah.
And again, didn't work. Let's bring another system. So the system was kind of the problem solver. And I think in the organization, data is a problem solver. And turning and making data a first-class citizen in organization, that's what will make a difference. A knowledge graph will work only after company will decide that data is important, regardless where this data is located, how it's stored, and who can change it. So when the company will make this shift, they will understand that they can make their digital business rather than application business. Because somehow Google knows about me everything, and knows that at 9 a.m. on Saturday, I'm driving to a particular place with my children and reminding me that I need to leave on time. So that's because Google decided that their data is a fundamental thing of their business. So the same about manufacturing organizations. So manufacturing organization decide they want to know everything about what they do. That's what will make this knowledge graph efficient, regardless if the data is in Excel, if the data in PLM, if the data is in ERP, and any other places. Their minds will be connected and focused on how to bring this data, so they will make the right decision all the time. So that's just a fundamental business change in terms of how you operate and how you build this. Although, and then there is a time factor, because technically you can acquire data from all systems and it will become available to a certain degree. That's by itself super important. But with ECOs, there is an element of time which must be included in the equation. And why so? Because when you have a complex product, you might have overlapping changes. And overlapping changes hurt organizations tremendously, because they are lining in the chain. So when you start changing one, you cannot change the second, and it's kind of thing that if you're going back to our conversation about fast development and fast releases and fast new product introduction, so you have changes that you need to make, and the another change can add you another week until people will make analysis. So making this tools that are capable to identify these overlapping changes and resolve those conflicts can be a significant unblocking factor if you're managing change requests. First was if people need to approve and they do not approve. That's kind of easy, although not always. But the second thing is a concurrency in the changes can bring a lot of complexity. Brings a lot of complexity, needs to be resolved.
I think it probably plays well off one of the questions here, which is like, how do you communicate this out? And I think one of the things we often leave behind here is sort of we're very visual people. Like engineers look at things. It might be numbers, it might be models, it might be problems, it might be parts that failed. Like we look at stuff. When you're looking at changes too, like I think it's very true. You gave the example of like visualizing what's actually changed so that you understand what's going on. I think that's one of the most impactful things you can do today is be extremely explicit about what's being changed. Like I'll give you an example. We help companies do cost reduction events. Most of the tooling they use is a spreadsheet or a SharePoint site to keep all those ideas. They're random obtuse ideas in a sheet that someone has to go then dig through all the data to figure out exactly what they mean. Because of that, I had a guy tell me last week that they did the event week long. It then took 8 weeks for them to send out the collected spreadsheet. And then it took him a week to understand what the comments were because he'd forgotten over the 8 weeks what they meant. And it's like the simple example, something would change. If you send out something with a long part number that you're not familiar with, that has no visual associated to it, like why are you spending millions of dollars building that model in the first place if you're going to just send it out as text-based updates? So I think there's a visual element there, like, oh, like there's something cool. I think with a BOM too, for doing like a diff, you can do with the model. There's lots of opportunity. But if you look at software developers, the most critical part of reviewing a PR is looking at the diff between what's actually changed, what's been added, what's been removed, what is the scope of what I'm doing. We don't do that very well as engineering teams. So I think that's the second part. It's like the communication of like, what are we truly talking about is really important. And the simpler you can make that to consume, the more likely the right people are going to speak up on it too. So it's like, I agree with you. Like, I think on the data side, it's defining where something's created and how it gets consumed in other places, and then mapping it all together. On the communication side, you've got to make it very simple and visual, in my opinion, or else it's going to be hard. And it's not an easy problem. There's not perfect tooling, something we're working on today, but it's going to take an army to make that visual because there's a lot of data, there's a lot of information.
I can just bring you one simple example historically for what we did at OpenBOM. So we introduced a very simple feature. It's an image for bill of materials. You know, when we introduce it, the original, what we want to make it nice. It's clearly became one of the most important things that people want, because people want to visualize anything. And so they put it in every place. And ultimately they said, oh, we just want to see part number and the image. And it eliminates mistakes, because as much as someone can memorize part number, it doesn't work for most of people, and people want to see it visual. And you spot on comparison. So the BOM compare, design compare, all the things really can make people life easy, because we don't remember anything, and engineers don't as well. So to have them this visualization, it's a big pain relief.
All right. I think this is the last set of topics before I kind of ask you all about your views on the future. So let's talk a little bit about going from, traditionally engineering systems to manufacturing or supply chain systems. So that includes things like EBOM to MBOM, and also the transition from PLM to the famous 3-letter ERP. Oleg, to borrow your words, can you speak a little bit about that? I'll hear from you first.
Sure. It was a long time definition that was called throw it over the wall of manufacturing. So you do design, somehow finish it, throw it over the wall, and then manufacturing people looking at this and saying, well, that's crazy. Those engineers, what they usually propose is crazy, so we need to change it, this and this and this, and then we manufacture, and then product look different from what it was designed. Again, we probably have heard the stories. I think when we speaking about transition between those systems, is that first these walls need to be demolished, and it goes back to our conversation about how to communicate and how to make processes going across different silos in organization. So it's clearly two silos, two organizational departments that they have their own responsibilities and their own objectives. But the most important one is how they can iterate between them during this process, because throwing over the wall and saying, I am done, now you make it, will not work. So what brings here a huge and important question about how the process and the fundamental part of this process is information flow. How this information flow goes between those systems. It's less important how to call those systems ERP or PLM. It's more important how this process, organizational process, makes information visible and makes a decision impacted by both sides. Because let's take a simple example, BOM costing. In many organizations, BOM costing is not done efficiently, and we're hearing about this a lot. But what prevents people from making easier BOM costing is because you only can do BOM costing if the information is in this famous ERP system. Before that, you don't have information about costing. You cannot do it. So how to make it work? It's really to bring the information earlier visible on manufacturing side, and also make this information from manufacturing production system earlier visible on the engineering side. So that's the core of the whatever you call it, PLM to ERP or EBOM to MBOM. So that those are things that really impact how systems are organized. This question about can your PLM system integrate with ERP? It's probably one of the most frequently asked in all integrations. What is interesting that as many people are asking about this, what they are missing is how they design information flow in the organization before they think about integrations. So for most of parts, what we hear from people is, oh, can you just mirror systems? This cannot work. Like it's the conventional thinking that if you make both systems identical, but then why do you need two systems? Because you have two different processes and you need to have different information. So it's what is information flow is what important, but designing this information flow takes energy and thinking from organization. And this is where we are investing a lot of thinking about how to make it simple, also from tools perspective, and also from a visibility standpoint. So how to make these tools that helps to transform data, because data must be transformed, and also how to make data available from both sides. That's something that can simplify it, but those processes are very complex. So make the streamlining of this process, that's something that can make it easier, and make this information flow easy. That's something that will make it more effective and bring more effective decisions to people. So that's just my take on this, and I'm interested, Adam, what you see from your experience. How is it happening, and how it impacts designs, and how it impacts the decisions that they can during the design time?
I think the thing you said first about, what is the flow of information you want is like ultimately where most people don't start. And it's the only part that truly matters. We get questions all the time about, do we send this data here? Do we take this data back to PLM? And the truth is, whether it's a system of record or system engagement or a random tool from another industry, the most important part is to know what data needs to be where and when, which part authors that data and which part consumes it. And then be smart about that, especially with these web-based tools. You do not need to be exporting PDFs. I get the question all the time for customers who say use Windchill or Teamcenter, integrate with CoLab. They push a file into CoLab because we need to consume the 3D model to be able to review it. We then produce a ton of communication, information, data, and an audit trail. That audit trail is immutable. It's always going to be up to date. It's always going to be there because we don't delete it. The first question is always, can you put that whole audit trail back into Windchill? So my first question to them is usually why? And they'll tell me because of ISO. And most of the time, the way we do it is we actually put the link back in Windchill, because then you'll always actually have the complete accurate record tied against the object, rather than taking a whole bunch of data that's a snapshot in time, putting it in a PDF and dropping that in Windchill. It's a different mindset. but it's like something we push back on pretty hard. For most part, you can get it out if you really want to. For comfort, you can. If you're thinking about it, the most logical way is, okay, the record system has my file. I can see on the record that there's a review happening. There's a link right here to it. It opens up the entire thing with all the context. And then let's just say some of those issues tied over to the software team, maybe we're going to integrate that with Jira. And then that links to Jira. But that's how it should be. Software development, that's how it works. There's so many tools built into our GitHub ecosystem and our Slack stack. I can't even tell you which ones are which anymore. And I think that's a good thing because it knows you're working on the right data and you don't care so much about who owns it. That's an architecture problem. Something to think about throughout the business.
Yes, there is one more thing to add here. There are many people that will agree with you about data and data flow, and it seems logical. But also keep in mind the business models. The business models, even no one will agree and will acknowledge this. The business models of today's PLM and ERP systems is in ownership of data. So, and ownership of data plays an important role. Who owns the data? That's who owns the business. And that's no one cancel this. And if the PLM system in the company owns the data and says OpenBOM is mine, and then means more business. And it's needs to be changed. So if business models will be changed, in your example with the Slack and other tools, you said, I don't know where they exist, but I know how to consume it. So if the business model will be changed towards data consumption, then we have a chance because people will be less concerned about who owns the data, but more concerned how to make data efficient. But that's a big change in the organization and business. And that's where I see a big moment when it starts happening. When it will start happening, people will understand that it can change the processes.
Very nice. All right, Adam, maybe you can put a bow on all of this by talking about a theme that I think has been running through a lot of these conversations, which is the idea of a system of record versus a system of engagement, which you've brought up a couple of times.
Yeah, I mean, I think at the end of the day, like no matter what you call these tools, it goes back to like, what are you trying to achieve first? Like who is there? What are the processes? And then augmenting it with technology. The big thing that Oleg and I will talk about is that, you know, even a big PLM system, if you look at the new versions, like 3DX as an example, they've got a ton of applications built inside 3DX. So within 3DX, they've almost created like some parts are for records, some parts are for engagement. They're almost doing that within their own tooling now. The whole ecosystem needs to become this because all this data is everywhere. As products become more electrical, more software driven, they're completely different tools that do not work very well in today's traditional MCAD stack. So the way I think I look at it is, you know, you've got some tools that are meant for record keeping, some that are meant for driving people to work together. Those two things need to be in harmony. And the most important part is what Oleg and I have been talking about, which is thinking about where does data need to come from and go to ultimately help people make good decisions. And at the end of the day, the sooner we all accept that there isn't going to be one tool that does it all and that there's going to need to be best in breed plugged into some parts of that and do a good job of that, I think the better. I know there was a question there about MBSE and the tooling. As an example, like CoLab today would not support all of that. Down the road, though, in the next little while, stay tuned, we will integrate with tools that enable those types of workflows, whether it's a requirements management tool or systems engineering. You know, we're not going to build everything under the sun. That's not the way we see the industry working. We're not going to build a PLM because we believe these companies have already done, you know, what's a very complex job. They've done it well enough that now we can augment in other ways. So it's about understanding where you fit, where the data needs to go, and then plugging those things together.
Oleg, any closing thoughts?
Yes, I would put in front of everything that is changing in manufacturing and engineering, I would put the information accuracy. So we want to work with accurate information, regardless if we are in engineering, we in production, and we are in maintenance. So the most hurting parts of all these environments is that we cannot live with the synchronizing data on daily basis or synchronizing data on weekly basis. So we want to live right now, right here, with the information that can be used for making decisions. Adam, you speak about making the right decision. You can't make a right decision if you don't have right information, and this information is not available. So that is a chain process that, you have right information, you make right decision, you can mitigate risks. If those are risks are supply chain, if those are risks are compliancy, and all this information must be available to people. And that's what will force companies to change their business models. And as we started with OpenBOM, with the word open, because the fundamental belief is that data is shareable and available to people regardless of environment. Yes, of course, access control, but that's what will make systems to behave differently. And the second is that everything is connected. So networks are becoming the most powerful mechanisms in the world and in business. Look back 15 years, the most successful companies were using network paradigm to change the world and the way they operate. And the same will be happening in engineering and manufacturing. So you cannot build an effective supply chain with the connected 5 databases that you cannot transfer data without screaming and yelling. So that just cannot happen. It should be something different. And once company will start understanding, then they will see more network and the data in an accurate way available to people.
Excellent. All right. Well, there's plenty of things that we didn't get to dive into, so maybe we'll have to do one of these again in the future. We're going to be sending out an email with the recording. If you have further questions or topics you'd like to see these two dive in on, feel free to hit reply and just send an email to me and let me know. But thank you all for attending. Thank you, Oleg. Thank you, Adam. And I hope everyone enjoys the rest of your afternoon.